the limit at infinity. So the limit at infinity, the limit when x tends to infinity of f of x, when x approaches infinity. So let's evaluate this problem when the limit when x tends to infinity, or when the limit is at infinity. So the question says that evaluate lim when x tends to infinity, 4x minus 3 over 2x minus 5. Now, how to evaluate this problem? Now, use the divide the numerator and the denominator by the highest power of x. Divide the numerator and the denominator by the highest power of x occurring either in the numerator and the denominator. Now, for this problem, the highest power of x occurring is x. So we are going to divide the numerator and denominator by the highest power of x, by x. So we say the limit when x approaches infinity, 4x divided by x minus 3 divided by x. This is divided by 2x divided by x minus 5 over x. So now x can cancel x. X can cancel x here. So we have the limit when x tends to infinity of 4 minus 3 over x divided by 2 4 minus 3 over x divided by 2 minus 5 over x. Now, this can also be written that as lim when x tends to infinity, 4 minus 3 times 1 over x divided by 2 minus 5 times 1 over x. Now, for those of you that don't understand how I got this 5 times 1 over x, 5 whole number 1 over x. So if we have, for example, you have 3 over x, this can also be written as 3 times 1 over x. So 3 times 1 over x can also be written as 3 1 over x. So that's how I got this. The 3 1 over x, 3 times 1 over x. So we have the limit of when x tends to infinity, 4 minus, okay, I think I should enclose it in a bracket, 1 over x, 2 minus 5 bracket 1 over x. So now the limit when x tends to infinity, 4 minus 3 number 4 minus 3 in bracket 1 over x over 2 minus 5 in bracket 1 over x. Now we can take the limit of each term inside every term here. So we say the limit when x tends to infinity, 4 minus 3 lim when x tends to infinity, 1 over x. This is divided by the limit when x tends to infinity 2, limit of 2 when x tends to infinity, minus 5 lim 1 over x when x tends to infinity. Now we know that the limit when x tends to infinity of 1 over x is equal to what? 0. So we have 4 minus 3. The limit when x tends to infinity of 1 over x equals to 0. So substitute it with what? 0. Divided by 2 minus 5, 0. So this is equal to 4 minus 0 over 2 minus 0. So this is equal to 4 over 2, which is equal to 2. So this is our answer. Now let's try another example. X squared plus 3x plus 2 divided by x squared minus 2x plus 7. So don't forget that recall that the limit when x approaches infinity of 1 over x is equal to 0. Don't forget this law. So now the next thing to do, the limit when x approaches infinity, x squared plus 3x plus 2 divided by x squared minus 2x plus 7. So you divide the numerator and the denominator by the highest power of x occurring in either the numerator or the denominator. So the highest power of x occurring either the numerator or denominator is what? X squared. So you are going to divide the numerator and denominator by x squared. So we say the limit when x approaches infinity, x squared divided by x squared plus 3x divided by x squared plus 2 divided by x squared divided by x squared divided by x squared minus 2x divided by x squared plus 7 divided by x squared. So x squared divided by x squared is what? 1. So x cancel here, 1, x cancel here, remain only x. So for the numerator, the limit when x approaches infinity, for the numerator, we have 1 plus 3 times 1 gives you 3. 3 over x. Only one x is remaining here, because this x has cancelled this x in the denominator side. So we have plus 2 over x squared. So divided by x squared, cancel x squared is 1. So there's 1 x here, cancel here, gives you only x. So we have that 1 minus 2 over x plus 7 over x squared plus 7 over x squared. So this can also be written as the limit when x approaches infinity, 1 plus 3 in bracket 1 over x plus 2 in bracket 1 over x squared divided by 1 minus 2 in bracket 1 over x plus 7 in bracket 1 over x squared. So you know how we got this, how I changed this in the other example or the other question we treated. I explained how I converted the 2 over x squared to 2 in bracket 1 over x. So you can go back and revise it. So now the limit when x approaches infinity of 1 plus 3 lim when x approaches infinity of 1 over x plus 2 lim when x approaches infinity of 1 over x squared. This is divided by the limit of 1 when x approaches infinity plus 2, so for the denominator, plus 2 lim when x approaches infinity 1 over x plus 7 lim when x approaches infinity 1 over x squared. Now we know that the limit when x approaches infinity of 1 over x is equal to 0. So wherever we see the limit when x approaches infinity, wherever we see the limit when x approaches infinity of 1 over x, we replace it with what? 0. So lim when x approaches infinity of 1 is 1 plus 3 times lim when x approaches infinity of 1 over x is 0 plus 2 times the limit when x approaches infinity of 1 over x is 0 divided by limit of 1 when x approaches infinity is 1 plus 2 or 2 lim when x approaches infinity of 1 over x is 0 plus 7 lim when x approaches infinity of 1 over x squared is 0. So this is equal to 1 plus 3 times 0 gives you 0 plus 2 times 0 gives you 0. 1 plus, okay, this is minus actually. So 1 minus 2 times 0 gives you 0 plus 7 times 0 gives you 0. This is equal to 1 over 1. 1 over 1 is written as what? 1. So this is our answer. Okay, for the third question, feel free to pause the video and evaluate the third question. The third question says, the limit when x approaches infinity, 3x cubed plus 2x squared plus x plus 1 divided by x cubed plus 2x plus 5. Now we know that the limit when x approaches infinity of 1 over x is equal to 0. So we have the limit when x approaches infinity of 3x cubed plus 2x squared plus x plus 1 divided by x cubed plus 2x plus 5. So now, the next thing to do, divide the numerator and denominator by the highest power of x occurring either in the numerator or in the denominator. So the highest power of x is what? X cubed. So we have the limit when x approaches infinity, 3x cubed divided by x cubed plus 2x squared divided by x cubed plus x divided by x cubed plus 1 divided by x cubed over x cubed divided by x cubed plus 2x divided by x cubed plus 5 divided by x cubed. So we have the limit when x tends to infinity. X cubed can cancel x cubed, so we have 3 plus 2x cancel here, we have x, only x remains, so 2 over x plus x cancel itself 1, x cancel here is what? X squared. 1 over x squared plus 1 over x cubed. So this is divided by x cubed can cancel x cubed 1. X cancel itself 1, x cancel here gives you x squared. We have 1 plus 2 over x squared plus 5 over x cubed. So the limit when x approaches infinity, this can also be written as x plus 2 in bracket 1 over x plus 1 over x squared plus 1 over x cubed divided by 1 plus 2 bracket 1 over x squared plus 5 bracket 1 over x cubed. So from the first question we evaluated, I explained how to convert from 1 over x cubed, 2 over x cubed to 2 bracket 1 over x squared. So you can feel free to go back and revise it. So the limit when x approaches infinity of 3 plus 2 lim when x approaches infinity of 1 over x plus the limit when x approaches infinity of 1 over x squared plus the limit when x approaches infinity of 1 over x cubed divided by the limit when x approaches infinity of 1 plus 2 lim when x approaches infinity 1 over x squared plus 5 lim when x approaches infinity 1 over x cubed. So recall that the limit when x approaches infinity over of 1 over x is equal to 0. So we have lim when x approaches infinity of 3 is 3 plus 2 lim when x approaches infinity of 1 over x 0 is equal to 0 plus the limit when x approaches infinity of 1 over x squared equal to 0 plus the limit when x approaches infinity of 1 over x cubed is equal to 0. So the limit of 1 when x approaches infinity is 1 plus 2 lim when x approaches infinity of 1 over x squared is 0 plus 5 lim when x approaches infinity of 1 over x cubed is 0. So this is equal to 3 plus 2 times 0 is 0 plus 0 plus 0. 1 plus 2 times 0 is 0 plus 5 times 0 is 0. So we have 3 divided by 1, so which is equal to 3. Please like, share, and subscribe. See you in our next class.